Welcome to Power Machines N6. This is a video on refrigeration. Before I begin, I do want to say that all the notes are available upon request. That is the notes that I am going to use in this presentation. And the same applies to all the notes that I've used in other videos. Okay, they are all available upon request. It has come to my attention that some of the people who watch my videos, they often have to pause to write down everything that's written on the slide, and then they press play again, and then they will pause again later to write down what is written on the next slide. That is cumbersome to do. So if you want to have access to the notes, they are all available upon request. You just need to get in touch with me and we will arrange how you can have those notes. Okay, so bear that in mind while you watch this video. Let's begin. So before we speak about refrigeration, let us begin by remembering that heat will travel always from a substance that is at a higher temperature to a substance that is at a lower temperature. Okay, you can imagine maybe an egg that you just boiled and it is very hot, and you take that and you put inside of a glass of water, okay, with water in it. And of course, what will happen is that the heat will travel from the egg into the surrounding water, because the egg is at a higher temperature and the water is at a lower temperature. So heat will keep on traveling like that until a state of equilibrium is achieved, where now the egg and the water are more or less at the same temperature. And so with refrigeration, we take advantage of that kind of understanding. For instance, if you have a cooler box, let's say you have a cooler box and you bring a bottle of Coke that is warm, and then you have ice inside of your cooler box, and then you put that bottle of Coke inside of the cooler box, what will happen because the Coke is at a higher temperature than the atmosphere and the ice inside of the cooler box, what will happen is that heat will travel from the Coke into the ice and into the atmosphere that is inside of the cooler box. And so it will travel from the Coke like that until the Coke is going to be at a cooler temperature and more or less balance its temperature together with the temperature that is inside of the cooler box. And at that moment, heat will stop traveling. Okay, but using a cooler box to achieve refrigeration is not sustainable, because eventually what will happen over time is that the ice is going to melt, and the capacity of the cooler box to continue to keep your bottle of Coke cool is going to degrade over time. Okay, so eventually that bottle of Coke will not be as cool as it initially was, because the refrigeration process would have been now interrupted, because the cooler box cannot sustain it for a long period of time. And that is where the fridge come in, and any refrigeration machine that you know, because with a fridge it is very possible to maintain the refrigeration continuously as a cycle. But the way to do that is to now begin to add certain important components to the fridge that will make sure that it becomes possible for the fridge to always maintain a certain temperature inside of the fridge. Okay, and in that way, because the temperature is maintained at a constant level, then heat can always be extracted from whatever it is that you put inside of the fridge. Okay, and so that's the difference between a fridge and a cooler box. They both are doing refrigeration. However, the cooler box is not doing it in a sustainable manner. But with a fridge, the refrigeration is sustained, because we have a refrigeration cycle, a process that is continuously being repeated. And in that way, we can maintain a certain temperature inside of the fridge and extract heat from whatever it is that we are putting inside of the fridge. And so let us look at a typical fridge. And so you've often looked at fridges and you looked behind fridges, and you saw different components, but you didn't really know what you were looking at. Okay, but today I am going to make that very clear to you, so that the next time you look at the fridge, you understand exactly what it is you're looking at, and what is the purpose of each of the components on that fridge. So let's begin. First of all, of course, you can see the plug here, okay, at the bottom. I did not label that because everybody knows what a plug is. But let us begin with this thing here. You've seen it on every fridge. It's usually at the bottom. There will be like a small opening at the bottom of the fridge, behind the fridge, and that is where you will see this thing here. You know, it looks like a spherical, somewhat cylindrical shape or box at the bottom of the fridge there behind. And some people refer to it as the motor, but its true name is actually the compressor. Okay, it is a motor, but it serves the purpose of compressing the refrigerant. Okay, so it is a compressor. Okay, it is a compressor. That spherical, somewhat cylindrical shape at the bottom of the fridge, that box, is the compressor. Okay, it's a motor, but its purpose is to compress, so a more accurate name for it is the compressor. Okay, then the refrigerant will then travel outside of the compressor into these coils, if I may call them coils. Okay, and again, if you want, you could stand up and go look at your fridge and look behind it. You will see these coils here like that at the back of the fridge. And so these things, okay, this whole system that you see here of these tubes, together with the tube that you see on top of that bar that is horizontal at the top, and the one that is horizontal at the bottom, and you may even have more than two, okay? This here constitutes what we refer to as the condenser. And the purpose of a condenser is to condense, you know, and you know what condensation is to turn a gas into a liquid. So in this case, it's the refrigerant that is going to be turned into a liquid by the condenser. So these coils that you see here are called the condenser. Okay, all of these here, this whole thing is called the condenser. Okay, and then you also have a filter, which is not really going to be of importance to us, okay, in our calculations or in solving problems on refrigeration. But it's important to know that in a refrigerator or in a fridge, one of the components that you have is also the filter. Okay, and it's immediately after the condenser, there you have the filter. And then after the filter, you also have a metering device. Now here you will see that it's impossible to see really because it's so small. Okay, the metering device is so small, so it's hard to see it here, but it's somewhere after the filter. You have a metering device. It's also referred to as the expansion valve or also the throttle regulator. So all these names refer to one and the same thing, the metering device or the expansion valve, and it's also commonly called the throttle regulator. And the reason it's called throttle regulator is because throttling takes place here where you have the metering device. Okay, and after the metering device, you have another component, which is the evaporator. And these are, you see the coils that you see on the freezer here, because on top of this small fridge here is the freezer section of that small fridge. And so the coils that you see around the freezer, all that represents the evaporator, okay? And the evaporator, you can think of it as a condenser, but that works in reverse. Instead of changing gas into liquid, but now we are changing things into gas. Okay, so that's why it also has a coil shape, but in this case we take something that is liquid, or sometimes even it can be a wet vapor, but then we evaporate it and turn it into maybe dry saturated vapor or superheated vapor. Okay, so that is the evaporator there. Okay, so I hope with that I will advise you at this point of the video maybe to pause the video and go look at the fridge and see if you can identify all these parts. Okay, very, very important, so that next time you look at the fridge you know exactly what you're looking at, and that's very good knowledge to have as an engineer. And so let us begin to look at what each of these components do. First, let's begin with the compressor. When the refrigerant gets in the compressor, naturally, because it is called a compressor, it will of course compress the refrigerant. And what happens when you have compression? Think about that for a moment. When you have compression, what happens? If you have a substance and you compress it, what will happen? Of course, when you compress something, its volume is going to reduce. And if the volume of something reduces, imagine you have a substance and you compress it and therefore its volume is reduced. So what happens? Because it is now compressed, the pressure inside of that substance is going to go up. And also the temperature of that substance is going to go up. Okay, and so that is what happens with compression. Okay, and so therefore after the compressor, what will happen? You will have a high temperature in the refrigerant and also a high pressure in the refrigerant, and this refrigerant is going to be in a vapor state. And at this stage I just assumed that you knew what we refer to as a refrigerant, but if you do not know, I am going to define to you what a refrigerant is. Basically, a refrigerant is the substance that is used in the cycle of refrigeration, and it undergoes different state changes. Okay, it will change states. Sometimes it is liquid, sometimes it is wet vapor, sometimes it is superheated vapor, and so on and so forth. But it is that substance that is going through the cycle of refrigeration, the substance that is moving through all these components of the fridge. That is what we refer to as the refrigerant. And usually when you buy a fridge, at the back of the fridge you will see some sort of a chemical symbol written there, and usually that will represent the refrigerant that this particular fridge is using. Sometimes it can be carbon dioxide, sometimes it can be methane, okay, and so on and so forth, okay. And so it is the refrigerant that is moving through the different components of the fridge here that I described to you. And so as I was saying earlier, after the compressor, the refrigerant is going to be at a high temperature and high pressure, and the state in which it's going to be is vapor state. And usually it is superheated. Okay, usually the state of the refrigerant after the compressor is superheated. Okay, it is in the superheated state. And then after the compressor, as you can see, the purple arrow, okay, you can see that after the compressor, the refrigerant is going to come and get in these coils here that represent the condenser. Okay, so after the refrigerant leaves the compressor, it gets into the condenser. And remember what I told you earlier, the purpose of the condenser is to turn the gas into a liquid, which means that after the condenser, where you see the green arrow here, that is after the condenser. The condenser is here, so it comes in from the compressor into the condenser, and then it comes out of the condenser where you see the green arrow. So that will mean that the state of the refrigerant where you see the green arrow will have to be liquid, because the purpose of the condenser is to turn a vapor into a liquid. So the state of the refrigerant is going to be liquid after the condenser. However, the pressure is still going to be the same pressure that you had after the compressor, but the temperature is going to drop. Of course, a liquid will have a lower temperature than a vapor, okay? So that is why you see where we have the green arrow after the condenser, we have a low temperature, but the pressure is still the same pressure that you had after the compressor, okay? It's still a high pressure. And the state of the refrigerant after the condenser, it's liquid, and it is always in the liquid state after the condenser. Very, very important. Then after the condenser, the liquid will go to the filter, but like I said earlier, the filter is not of any interest as far as the physics of refrigeration are concerned. And then after the refrigerant passes the filter, it gets here where you have the throttle regulator, or the throttling device, or you could call it the metering device, or the expansion valve. Okay, so the refrigerant will get to that little device there. Okay, and then the purpose of the expansion valve is to expand. Okay, to expand the refrigerant, okay, before it gets into the evaporator. And so after the throttling device, you can see we now have the blue arrow here that represents the refrigerant before it gets into the evaporator. And at that stage, it can still be liquid, or it can be a wet vapor usually, okay? And so this is what we have here. And of course, because expansion has taken place, remember this component is called the expansion valve. Because expansion has taken place, you can expect the pressure to drop. So we had a high pressure after the condenser, then we go to the expansion valve, expansion takes place, so the pressure drops, because when you expand something, you increase its volume, okay? So the pressure will drop. So that's why now after the expansion valve, you have a low pressure, and the temperature is also low, and the state is liquid, but not always liquid, okay? Sometimes it can be a wet vapor, okay? So that is why I will not say that it is always liquid, but I can say most times it is liquid, okay? After the expansion valve, which is also called the metering device or the throttle regulator. And then after that, we have the evaporator, okay? After that, we have the evaporator. So when it leaves the metering device, the refrigerant is going to get into the evaporator. And the evaporator, what does an evaporator do? It will increase the temperature of the refrigerant. I mean, if you have a substance and you want to evaporate it, you need to increase its temperature, okay? And that is exactly what it does. And so after the evaporator, you have that red arrow here that represents the refrigerant that has exited the evaporator. And so after the evaporator, the temperature, of course, we can still say it's low, but it's not as low as it was before the evaporator. It is only low in comparison to the temperature that you have after the compressor, okay? Very, 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 very important. Okay, so let us bear that in mind. Okay, and the pressure is still low, but the state in which it will be after the evaporator, like I said, it is an evaporator, so it will evaporate the gas. Okay, it will evaporate the gas. It will evaporate the gas. Very, very important. Very, very important. And so it's usually it will evaporate the refrigerant, not the gas. I meant to say it will evaporate the refrigerant because it's an evaporator. And so when it is in this vapor state after the evaporator, it will usually be either dry saturated or superheated, okay, after the evaporator. It's either dry saturated or superheated, okay? But it can also be wet, okay? So again, these things here, I am giving you some general understanding, but do not take them as it's always supposed to be like that. You could get a question where it is different, okay? You could get a question where it is different. But after the evaporator, it is usually wet or dry saturated. I said dry saturated or superheated, but I think the superheated case is rare. It's very rare, but it will usually in your questions be wet or dry saturated, okay? Very, very important to bear that in mind, okay? So having said that, we can go on to the next slide.